Okay, today I want to present OA3 level 3 modify about a DC machine. My name is HAKIMI ROSLAN, MATRIK number 2110926. Okay, for introduction, the DC motor uses a DC current to transform electrical energy into mechanical energy. The main advantage of using this is that we can control the speed and it occupies less space. Okay, I want to discuss three types of the DC motor. First, a series DC motor, shunt DC motor, separate excited DC motor. In the case of the permanent magnet DC motor, permanent magnets are used to create field flood. The other three types are classified based on the electrical connection between the stator and rotor, its of the then unique torque and speed. Okay, we can see a figure 1 equivalent series DC motor. Okay, the series DC motor allows a wire carrying the full armature current with the field with few turns. This kind of the motor generates a large amount of the starting torque, but the speed cannot be regulated here. If they are run with no load, then it might affect or damage. These are not the ideal option for variable speed application. Okay, next we can see about the figure equivalent shunt DC motor. The field circuit get the power direction across the armature terminal of the motor. Okay, the shunt DC motor, the field related to the armature winding in the parallel, or also known as a shunt. The shunt field can separate excited from the armature winding, and that is the reason it can be used for greater speed regulation and can also offer very simply reverse control. Okay, we can see the figure 3 equivalent circuit separate excited DC motor. Separate excited DC motor, the field circuit is a supply from separate constant voltage power supply. The field relate the armature winding in the parallel, or also known as a shunt. The shunt field can separate excited from the armature winding. That the reason it can be used for the greater speed regulation and can also offer very simple reverse control. Okay, methodology 50 produced for the DC motor. Firstly, connect the circuit of the figure 4 and 5, and second, have the instructor check your complete circuits, and third, before using the brake controller and magnetic powder brake unit, you must first calibrate the torque display of the brake control to 0 kg. And next, set the on knob to the 47 on position. And number 5, turn on the run the machine by the press start button. Next, increase the motor voltage to the rate 120 volts DC. The motor speed must not exceed 1770 RPM. Okay, next, manipulate the brake controller to the operate and set the torque to 0.1. And next, it record the motor current, feeder current, motor voltage and speed. Lastly, repeat from the step 2 by the decrease the on knob as 45 14, 35 13 to 25 20, 15 and 20, and record. Okay, next, for the DC motor, for the DC shunt motor, firstly, connect the circuit as the figure 4 and 5. Have the instructor check your complete circuit, and then before using the brake controller and magnetic powder brake unit, you must first calibrate the torque display of the brake controller to 0 nm. Okay, next, set the on knob to the 1050 position. Turn on the run the machine by the press start button. Increase the motor voltage to the rate 50 PD. See, the motor speed must be at 1070 RPM. And next, manipulate the brake controller to operate and set the torque to 0.05 kg. Next, record the motor current, field current, motor voltage and speed. Lastly, repeat from step 2 by decrease the on knob as a 1300, 100, 800, 600, 400, 200 and 0, and record. Okay, next, for the DC separate connector motor, Firstly, construct the circuit using the spacing as a figure 6, and let's set two voltage source separate as VT and VF. Next, connect the voltage source with a DC machine, speed sensor, and mechanical load with a constant torque. Okay, next set the VDC equal 120 volt. Next, set the volume in the restart as 75 ohm and 0 tap position. Next, set simulation control time step as 0.001 and total time step as 4 seconds. Lastly, run and compare the speed and repeat by increase the restart on volume. We can see the figure 4 schematic diagram, figure 5 hardware DC machine, and next figure 6 the schematic diagram. Okay, for the result, for DC series motor, we can see the table 1 measure volume of the knob, I ampere, F ampere, E ampere, and RPM. Okay, next we can see the figure 7 speed versus torque resistance. We can see resistance and RPM. We can see the decrease, right? Okay, the figure 8 current versus torque resistance is same, decrease. Okay, for the DC shunt motor, we can see the table 2 measure volume of the knob, I ampere, F ampere, E ampere, and RPM. Okay, for the figure 9 speed versus torque resistance is same, decrease. Okay, for the figure 10 current versus torque resistance is increase. Okay, for the DC separate excited motor, table 3 measure volume of knob, I ampere, E ampere, E ampere, and RPM. Okay, this for the figure 11 voltage per current is decrease. Okay, for discussion, in this OER 3 we can discuss about the DC series motor. First, we discuss how to understand the limitation parameter and demonstrate the top speed characteristic of the DC series shunt motor and separate excited DC motor. DC series machine, unlike with the shunt DC motor, there are only one especially way to change the speed of the series DC motor. That method is to change the terminal voltage of the motor. If the terminal voltage is increased, the first term in equation torque speed relationship is increased, result in a higher speed for any given torque. DC shunt machine, a terminal characteristic of the machine is a plot of the machine output versus each other. For a motor, the output quantity are the shunt, torque, and speed. It is important to realize in order for the speed of the motor to vary linearly with a torque, the terminal voltage supplied by the DC power source is assumed to be constant. If the terminal voltage is not constant, then the voltage variation will affect the shape of the torque speed curve. Another effect internal to the motor that can also affect the shape of the torque speed curve is a armature reaction. If a motor has a armature reaction, then as is a load increase, the flux weakening effect reduce its flux. In this section, we will discuss about the separate excited DC motor. Like other DC motor, this motor also have both stator and rotor. Stator refer to the static part of a motor, which consists of the field winding, and the rotor is a moving armature which contains armature winding or a coil. Separate excited DC motor has a field coil like that of a shunt DC motor. The name suggests the construction of this type of motor. Usually, in the other DC motor, the field coil and the armature coil both are energized from a single source. The field of the then doesn't need any separate section, but in a separate excited DC motor, separate supply provide for excited of the both field coil and armature coil. Figure below show the separate excited DC motor. For a separate source may be variable, but independent constant DC voltage is used for energizer the field coil. So those coils are electrically isolated from each other, and this connection is especially of this type of DC motor. Okay, lastly, we can explain about the calculation. In the calculation, OELDC machine teach you how to be able to demonstrate connection of a DC series. Okay, decision one motor and control the direction of the rotation of the motor. Besides, after complete this OELDC machine, we understand the limitation parameter and demonstrate the torque speed characteristic of the DC series and shunt wound motor. Next, we should able to understand the control and speed limitation of the DC series and the shunt wound motor. Lastly, in the characterization of the separate excited DC motor, we should be able to understand the speed control, torque speed trend, speed relation, and other limitation of separate excited DC motor. That's all for me. Thank you.